All right, related rates. The top of a ladder slides down a vertical wall at a rate of 0.15 meters per second. At the moment when the bottom of the ladder is 3 meters from the wall, it slides away from the wall at a rate of 0.2 meters per second. How long is the ladder? All right, so we're solving for a side length, so that's important to know. So now let's go ahead and draw a diagram of the situation. So here is the wall, and this is a triangle, obviously, because it's a ladder sliding down a vertical wall, so it would look something like this. So now, let's just put in our side lengths. So we have x, y, or let me do that in a different color. So x, y, and z. All right. And now, after you've done a diagram, the best thing to do is to list everything that the problem gives you. So it says that it slides down a vertical wall at a rate of 0.15 meters per second. So what's happening is that this part right here is moving down at that rate. So we have dy, dt equals negative 0.15 meters per second. And the reason it's negative is because it is going downwards, right? It's sliding down, so we have to put negative 15 here. So now we are also given that at the moment when the bottom of the ladder is 3 meters from the wall. Okay, so that's just saying this point right here is 3 meters from here. So we know that x equals 3 meters. We don't know what z is. We're solving for z, so z, I'm going to question mark. But we do know the rate at which x is increasing. We know that dx dt equals positive to 0.2 meters per second, right? Positive because it is going that way. So now we have enough information to solve this problem. So the way we're going to want to get the side lengths is that we're going to want to use Pythagorean theorem or some variation of that. But in this problem particularly, it is relatively easy to just use Pythagorean theorem. So x squared plus, plus y squared, of course, equals z squared. Okay, so here are different parts of our equation. So before we actually go ahead and differentiate this, it is important to realize the things that are changing in this problem and the things that are not changing in this problem. So x is obviously changing. We see right here that it's sliding away from the wall at a rate of 0.2 meters per second. So x is changing. It is a variable in this equation. We also know that y is changing. It says here the top of the ladder slides down a vertical wall at a rate of 0.15 meters per second. So y is also a variable. Now we are solving for z. Z is the length of the ladder. In no way do we know that the length of the ladder is changing. We only know that y and x are changing with respect to time. But z is constant. I mean, if I have this ladder, right? I have this ladder here, and it's sliding down and to the right. The length of this will never change. It's going to remain constant. This means that z is constant in this equation. So that's going to help a lot when we differentiate. So d dt. Now let's just go ahead and differentiate implicitly with time. So 2x dx dt plus 2y dy dt, of course, is equal to 0, equals 0. Now that is super helpful because now we can just go ahead and solve for y. We don't have to worry about an extra variable. We don't have to do some sort of system of equations or anything like that to solve. We can just solve directly for y because we already know what x is. So now let's just solve this equation in terms of y. So we're going to get y equals, and before I do that, let me just go ahead and divide by 2, get those out of the way. So y equals negative x dx dt over dy dt. dy dt. So now we can just go ahead and plug in values for this. So y equals, don't forget our negative, what is x? 3 times dx dt, which is 0.2 meters per second, 0.2, over dy dt, which is in blue. Dy dt is negative 0.15. Wait, hold on. 0.15. So whenever we plug in all of this, we get y equals to 4 meters, right? Because the 0.2 is meters per second, the 3 is meters, so it's meters squared over meters, and then a second over second, right? Let me write down what I'm talking about. So the 0.2 is meters per second, and the 3 is meters. So the top becomes meters squared over seconds, and the bottom is meters over seconds. So if we divide evenly, we're left with just meters. So y equals 4 meters. And obviously that makes sense because the side lengths should be in meters, right? So y equals 4 meters, x equals 3 meters. So we can go ahead and solve this using the Pythagorean theorem. So 3 squared plus 4 squared equals z squared. Equals z squared. So now we have, let's see, 3 squared is 9 plus 4 squared is 25. So 25 equals z squared, which means that z equals 5. And alternatively, you could have noticed that this is a 3, 4, 5 Pythagorean triple. So you could just skip that step right here altogether and just say z equals 5. Oh, 5 meters. We can't forget that. Z equals 5 meters.